Hello, my name is Kelvin Seibt, and I will talk about the capacities and applicabilities of Li-Fi networks, starting with a brief introduction. With the growth in the number of devices with wireless communication, due in part to the growth of Internet of Things area, it turns out that the amount of bandwidth consumed has been increasing proportionally. In this regard, the environments most affected by this growth are public places, where be a large number of users, different networks and structures come to generate interference or signal attenuation. As we can see, the origins of the problems are distinct, but one of the key factors that demands our attention in this topic is the saturation of the spectrum of radio waves. We tried to find an alternative technology that will present promising results, arriving then to the Li-Fi. Considering that all the workplaces require by law an appropriate illumination and that electricity is a basic service in all world countries, the Li-Fi shows to be suitable to mitigate these problems. So, having found this technology, this research has as objective to evaluate if Li-Fi could act as a substitute for Wi-Fi or only as a complementary technology. And this verdict will be made by listing comparisons with Wi-Fi and exploring the efficiencies of this technology. To give some background, some terms and mechanisms will be presented, since they will be vital for understanding of the discussions held throughout the work. Optical communication. Optical communication is any form of telecommunication that uses light as the means of transmission. Originally called Optical Wireless Communication (OWC), use wavelength in the ER spectrum for ER communications and visible light spectrum in visible light communication or VLC. Photodiode. Photodiode consists of an electronic device made of a semiconductor material, usually silicon. It has a semiconductor junction, which has the property of varying its electrical resistance according to the intensity of the light or number of photons in its incident. Li-Fi. Li-Fi is a VLC technology developed in 2010 through research conducted at Edinburgh University and led by Professor of Mobile Communication Haas. Became a public concept in 2011 when Haas presented the technology in his TED Talks. With the title "The Future is Bright, the Future is Li-Fi." Li-Fi, the data communication occurs basically by changing the light intensity of a light emission diode, which in turn modulated in a message signal and transmitted by wireless optical channel. So this is detected by a photodiode, which makes the demodulation and recovery of the message clock. In 2011, the IEEE released a standard for VLC called IEEE 802.15.7-2011, IEEE standard for local and metropolitan area networks, Part 15.7, short-range wireless optical communication using visible light. In our methodology, the observation method used was conceptual analytical, observing and assimilating other authors aligned with our objectives, thus adding new content to this work. The method of discussion of the results was explanatory research, separately analyzing various communications properties and assuming conclusions along the way. Starting for an initial reading of Ha's book, Li-Fi is presented as a complementary network to Wi-Fi wireless networks, aiming at spectrum relief and data traffic. So, topics have been listed to discuss key points of the two spectrum waves, given to find which characteristics cause this imposition. Well, about your modulation, we have that due to the physical capabilities of the components used, the information can only be encoded using light intensity. In consequence, the VLC can be used as an intensity modulation and direct direction IMDD system. This technique allows communication even if the lights appear to be off. The problem encountered with this modulation is that the signal must be real, unipolar, and non-negative. That limits the consolidated modulation schemes used in radio wave communication, because as the modulation speeds increase, they suffer more inter-symbol interference effects because of the collected frequency of the data. So a more resilient technique like orthogonal frequency division multiplexing (OFDM) is needed, which allows the use of adaptive byte and energy loading of different frequency subbands. At this point, both the book and Ha's paper remain with the same problem. However, in 2018, two solutions are already proposed, being them enhanced unipolar OFDM and spectral and energy efficient OFDM. About multi-access. Proper multiple access should allow multiple users to share their resources without cross-talking. In this case, access schemes of Wi-Fi communications can be adopted. In this sense, OFDM comes with an extension for multiple access called orthogonal frequency division multiple access (OFDMA). Single carrier modulation schemes such as pulse position modulation (PPM) or pulse amplitude modulation (PAM) require an additional multiple access technique divided by frequency, code, etc. An alternative option is to use LED color, and the corresponding technique for this is wavelength division multiple access (WDMA), reducing the complexity of the processing but increasing the complexity of the hardware. In this sense, no changes were reported in any of the articles, remaining in this format until the current moment. One of the points that may be detrimental to the multi-user experience will be addressed in the sales topic. Moving on to the next topic, the network structure. Power line communication (PLC) and power over Ethernet (PoE) present themselves as a viable backhaul solutions for Li-Fi installations. In this sense, Wi-Fi has an advantage, as it does not depend on a structure that uses data and energy in its communication medium. No changes were reported in any of the articles remaining in this format until the current moment. Uploading is cited as research focuses on maximizing speeds on a single unidirectional link. But for a complete system, full duplex communication is required. Existing duplex techniques used in radio frequencies such as time division or frequency division duplexing can be considered, where the downlink and uplink are separated by different intervals. The most suitable duplex technique in Li-Fi is wavelength division duplexing, with two communication channels at different wavelengths or using AR transmission. The first commercially available full duplex Li-Fi modem using AR light for uplink channel is from the company Pure Li-Fi. In Li-Fi, the topology adopted is point-to-point, while Wi-Fi is multi-point. Singh stated at his study, need of line of sight, and Harold complemented that a point-to-point redirection could be done make it look like a non-target communication, but the non-target communication techniques are still under study. Now about the cells I mentioned before. In the past, cellular wireless communication benefited from reducing the distance between base stations. By using femtocells, which are short-range base stations with low transmit power, low cost, and targeted for indoor deployment, the coverage was improved. However, the point is that careless deployment of small cells also causes interference between cells. This concept can easily be extended to VLC and is referred to as a talk cell. Since it operates in optical spectrum, the talk cell does not interfere with the macrocellular network, so it does not generate any additional interference. Haas predicted in 2015 that these Li-Fi cells would have a range of 5 meters, and in 2018 he concluded his thought by saying that in the 5th generation of the technology it will be up to 25 meters. The data rate achieved will depend directly on the optical technology employed. Commonly marketed LEDs are more cost effective, but they are attenuated by their chemical conversion, making the bandwidth around 2 MHz. Ignoring the cost, we can achieve incredible values. With RGB, red, green and blue LEDs, up to 8 GB can be achieved, and with laser-based light, a range of 100 GB. The use cases presented by Kendall and Jain, as well as Haas in their book, are closed office or residential environments, that is, short distances. But recently they have also focused in security, such as petrochemical plants and oil platforms where radio frequencies are often prohibited. Sync finally brings us applications in the underwater environment, which fits with Haas' idea of platforms in the middle of the sea. Finally, the question of Li-5 as 5G. We have that the visible light and infrared spectra are approximately 2,600 times the size of the radio frequency spectrum, and an alternative to the demand for the data traffic. Coupled with this speed that was laid out in the topic data rate with up to 100 gigabytes by second, Li-Fi fits in as a 5th generation technology. Haas, the creator, says that the adoption of this new standard along with the use of RGB lasers can bring up a new revolution to the area of communication. This would unlock the IoT in large scale in Industry 4.0 applications, as well as growth of projects that are currently in their infancy. One example is Light as a Service (LaaS) in the electric power industry, merging two large industries, the wireless communication industry and the electric power industry. So we come to the conclusions of the work. As Haas approached in the beginning of his book, Li-Fi is still just Wi-Fi supporting technology, and still has a long way to go to replace it. The complexity added to hardware to accomplish a good multi-user access and data rates make it a barrier to entry of ordinary consumers. The point-to-point topology points that multiply spaces in the same build will need a previous preparation of the network scheme. Without that, it becomes necessary for the acquisition of multiple devices to make possible the redirect of the signal. This brings up high use of hardware that, with the necessity of evolution of methodologies applied to Li-Fi, can quickly become obsolete, bringing an accumulation of electronic waste. However, it can already be observed that it is in fact a 5G technology with high transmission and bandwidth rates. Based on the selected articles, the technology has not yet undergone many changes since the regulation and creation of protocol for VLC communication. The same problems are still perceived, but some research results to add more solutions to these problems are already visible. Based on the results and tests cited by Haas, there is a great bet that the market will receive more prototypes and companies focused on this market, such pure Li-Fi. The existing technology today is still very affected by the interference between its communication peripherals and the noise by the particularity of sunlight impulses. With the consolidation of this technology, you will have the possibility of using it in places that are impossible to use Wi-Fi. Safety is a beneficial side where the use of light to transmit data does not penetrate through walls. On highways, for traffic control applications such as cars, they can have LED lights and can communicate with each other and predict accidents. Therefore, the key point of the search for solutions to problems in Li-Fi and your implementation seems to fall automatically with the passage of time, is the lack of radio band. The key point for the search for solutions to problems in Li-Fi and your implementation is the lack of radio band. Haas already made alarming predictions of increasing data use in 2015, and today it is a reality. We have some devices that demand communication with other devices in the environment, make carries in the cloud, and still have advanced artificial intelligence algorithms. In this case, we see a perfect environment for Li-Fi to act and its potential to be more and more explored. After reading the book, it is noted that there are still a large number of topics to be addressed within this technology. What stood out in the terms of need for study are the areas of signal modulation and access to multi-users. Therefore, teams direct the discussion of our solutions of these deficiencies will have much relevance in the area of communication.